Okay. All right. Well, first of all, welcome to our webinar, Adaptive Management and Approaches for Long-Term Success, Iterative Real-Time Approaches Tailored for the Highly Dynamic and Complex Nature of Contaminated Sediment Sites. We really appreciate your time and spending this next hour or so with us. So just as a quick note, we are recording this webinar for future use, and it will actually be shared with everybody in an email after the webinar. Okay, so we really have some great speakers today. Doug Tomchuk is a remedial project manager for EPA, focusing on the investigation and remediation of contaminated sediment sites. And before COVID, Doug used to have short hair. Craig Jones is a principal ocean and environmental engineer at Integral, specializing in hydrodynamics, waves, and sediment and contaminant transport. Outside of work, Craig can be found surfing and listening to Doug's surf rock band. Marsha Greenblatt is a technical director and water resources engineer at Integral and is an expert in hydrodynamics, water quality, and sediment investigations. In her free time, Marsha collects bike rides through national parks. I'm Stephen Benson. I'm an environmental engineer and senior consultant at Integral, working on evaluating remedial actions and designing and implementing cleanups at sediment sites nationwide. And I am located in Portland, Maine, where I'm relearning how little sleep you get when you have a new puppy. Okay, so for today, we're going to discuss how to plan for the post-remedy monitoring and how we can prepare ourselves, our clients, and regulators for what happens when the monitoring results are not what we expected or hoped for. The use of adaptive management in developing a site monitoring plan is an idea that can minimize uncertainty, reduce environmental risk, and prevent undue cost. It's not a new idea, but the actual implementation of it is, and it's one that's still being developed and refined. The speakers today will discuss how we can get from the concept of adaptive management to developing a monitoring program and its implementation. Craig is going to kick it off with a description of what adaptive management is, both in theory and practice. Marshall will then focus on how it can be applied to monitoring at complex sediment sites. And Doug will wrap it up and present it from a regulator's perspective and share a case study where adaptive management was applied. Afterwards, we're going to have a Q&A panel discussion, and we'd love to hear from you and discuss any comments and questions that you may have. We will open up to questions at the end of the presentation, but if you have anything that you want to note, you can add it to the Q&A in the chat bar, and we'll revisit those during the discussion. Craig, you want to take it over?
Absolutely. Thanks, Stefan. Howdy, everyone. It's a pleasure to be here with all of you. As we were discussing earlier, the only regret is that we can't all be together in person, but hey, this gives us a bit to all chat together and get some questions out there. As Stefan mentioned, please put your questions in chat, and we look forward to having a discussion afterwards, which we'll have plenty of time for. A little bit of history on adaptive management. In the 60s and 70s, adaptive management was first developed into more of a science practice, an engineering practice, and management practice, where it was looked at for natural resource, managing natural resources. The first documented adaptive management application in the United States was actually at Yellowstone National Park. And it was looked at to manage ecological resources in the national park and look at how moving forward into the future with different uses in the park, how they could better manage those natural resources to preserve a lot of those resources within the park. So adaptive management is by no means a new concept. In some ways, it's fairly new in the sediment realm. It's been in the past 20 years or so that we've been talking more and more about adaptive management. And certainly with the recent framework that has come out from the EPA, we're starting to get more and more ideas of how to actually apply it at some of our larger or more complex sites. I want to talk a little bit about complex project development and why we're really looking at adaptive management, what adaptive management means and what it's for. I'm going to cite some work from the offshore energy industry. And if we think about the offshore energy industry, it's actually a good corollary for us. You have massive amounts of capital being outlaid for these. I mean, we're talking billions to even trillions of dollars in some of these developments offshore. So they've spent a lot of time and energy really understanding where the project risks are coming from. It's also a complex and changing environment. Deep water ocean environment is one of the most complex, challenging environments to work in on the planet. And it's always changing and presenting new challenges for working in that environment. One thing that was done by some engineers at Shell Energy was looking at technical versus non-technical risks. And I think that applies very much to the type of projects we're looking at. Technical risks are really within the physical scope of the project, and that's the design of a remedy, that's a construction of a remedy, installation. And in that sense, we can essentially engineer our way out of many problems. Do we need a bigger dredge? Do we need a smaller dredge? Do we need to install silk curtains? Do we need to put our piping along here? This is what we need to do with our water treatment system. While these may be costly decisions and certainly important decisions to make, we can essentially engineer our way out of these decisions and challenges. And many times we understand those up front because a lot of our engineers have a very good experience working in marine environments, aquatic environments. Non-technical risks are the interactions of the project that are external, and that's the environment. That can be storms, hurricanes, other events that while we may model those a priori, we really don't necessarily understand the interaction and effects on any particular remedy we choose. Communities and stakeholders can change surrounding our environment. So a decade, 2 decades later, the site may look very different than it looks like today. There's a few other ideas listed here. Contractors. There can be contractor challenges that we didn't anticipate. There's examples of Superfund sites where the contractors didn't necessarily perform to spec, and that was not understood until 5 to 10 years later. That would be a non-technical risk. One of the things that was found by the Shell engineers is up to 70% of project failures, overruns, cost failures are due to non-technical risks. That's not saying that the technical risks don't fit in here, but the non-technical risks oftentimes being the ones that we don't see. So where does adaptive management come into this? Those non-technical risks, and even the realm of technical risks that we don't see coming down the pipe, are uncertainty. And adaptive management frameworks are really designed to help us address the uncertainty. We're never going to have perfect knowledge of a remedy moving forward. On the right-hand side here, I show a figure from EcoShape in the European Union. This has been done to manage living shoreline projects, natural resource restoration projects, even remedial projects throughout the European Union. And this is a neat execution cycle that kind of summarizes what we're looking at. First, we plan our activity. We plan our engineering activity, our remedy, whatever it is. And we establish monitoring objectives and information needs around that. We implement that monitoring and we implement that analysis and we evaluate that as it's going forward. If it's meeting the goals of the project, we continue to monitor, and even in some cases may reduce some monitoring if we see that we understand that that's not going to be a factor with our success criteria in the future. Or we may need to implement new or different kind of monitoring depending on how the success criteria is moving forward. The important part there is it is an iterative process, and it's truly iterative in the fact that we can evaluate and modify as we move forward. Essentially, our goal here is to convert uncertainty into opportunities for sustainability of our project and conservation opportunities as well. So the EPA has recently released the Superfund Sediment Assessment Monitoring Sheet, which proposes a good framework for adaptive site management planning. Here in this graphic, we see we set remedial goals. We're all familiar with setting remedial goals. Those could be sediment and tissue concentration goals that we know are going to reduce the risk at the site. Then we can implement an early action or some type of interim action, monitor the response of the system to that, and evaluate that. Adaptive management gives us a point where we can go back and review that early action and possibly modify it if it's not meeting the sediment goals, tissue goals, or other goals that we've set for the site. A critical point throughout this that underlies the bottom part is refining the conceptual model. As I mentioned, we're never going to know everything about a site, so we need to continually refine our conceptual model, and we need to continually update that with the information that we're collecting. And stakeholder engagement. This is not a one-sided thing. It's not just all on the PRP. It's not all on the EPA. It's not all on the stakeholders. This needs to be a collaborative process. And under the Contaminated Sediment Directive, it's advised that there's specify key indicators. So these are our parameters that we're monitoring. Trigger criteria are those parameters not meeting the goals that we've set forth. And then setting specific actions based on the attainment or non-attainment of that trigger criteria. And we're going to talk a lot more about that today because that is a critical part of the success of adaptive management plans. So I'm going to give you an example of a site that we worked on recently. Now, this is in a different realm. It's looking offshore off the coast of Oregon for the Pacific Energy Wave Site, or PAC-WAVE. And this is a site where we have a valuable offshore natural resources, economic resources in the sense of fisheries as well, very active stakeholder engagement. We have regulatory, from federal regulatory to state regulatory entities that are overseeing these activities. And we're looking at testing out different renewable energy devices. One of the key things that's come out of the adaptive management plan that's into the permit for this site is, first off, defining the stressor and receptor metrics. And we do that all the time. That is truly our site risk, and that's what drives our site risk. So moving forward on that, we design monitoring to look at those stressor and receptor relationships. And we integrate those so that we can better look at what's happening. And there's an adaptive management committee that's set up of the project developers, the regulators, and the local stakeholders. The important thing that we've done there is pulling the information together into dashboards so that everyone can review the data on the different risks that could be posed. Excuse me. Some of the risks at this particular site offshore of Oregon here are acoustics. So acoustics can disrupt marine mammals and other organisms in the area. And looking at what the acoustic monitoring is showing at the site. EMF is electromagnetic fields. So the cables to the site potentially disrupt critters in that way. Benthic, entanglement of marine mammals and other interactions. So including all this data in one place so that all the stakeholders, regulators, and the PRPs can better understand what's going on at a site are really the key to being able to assess and develop an adaptation of what our actions may be moving forward into the future. But the whole idea here is to really provide opportunities to recover from imperfect outcomes and provide for future improvement. Because our outcomes are never going to be perfect, but we need some metric to gauge how imperfect or perfect they are and whether that requires action or not. So overall, non-technical risks are a big primary source of delays, overruns, and project failures in large complex projects such as sediment remediation. Lessons learned from these other industries can help inform how we apply adaptive management at sediment sites. We want to address big issues and conflicts up front with our stakeholders, regulators, and PRPs. Everyone has their big issues. We need to get those on the plate up front so that we can collaboratively move forward with adaptive management and potential changes down the road. But overall, we're looking to develop certainty and opportunity with effective adaptive management. Thanks, and look forward to having a discussion afterwards. And Marcia, with that, I will pass it to you.
Thank you, Craig, and thanks for providing some context around with which to think about adaptive management. I'm going to focus on adaptive management at complex sediment sites, and in particular, how a thoughtful framework around the monitoring program is instrumental to the success of an adaptive management approach. So when do we want to think about applying an adaptive management approach at these complex sediment sites? Well, these sites typically undergo years of study. We collect lots of data. We collect multiple phases of data. We develop conceptual models. We often develop numerical models. And we work hard to develop an understanding of these sites. And I think we do a good job of characterizing them. However, despite our best efforts, there's still going to be uncertainty around our understanding of the site, for example, around our understanding of sediment and contaminant fate and transport, around the food web interactions, and importantly, how the system would respond to a remedial action. However, despite the uncertainty we have, it's usually clear that there's some action or set of actions that will reduce risk if implemented. By how much, maybe we don't know, or there's some uncertainty in our estimates. But adaptive management allows us to embrace this uncertainty and move forward with a remedy implementation and risk reduction. And it provides the opportunity to learn from the new data and adapt our plan, our management plan of the site as we go. So a framework for adaptive management that includes details on the monitoring program will provide some guidelines on how to think about and implement the site plan. And this is particularly important for stakeholder buy-in into what's a new approach right now and has a lot of unknowns. So the elements of a framework around monitoring would include defining the potential data needs. And this needs to be done prior to the implementation of a remedy. So identifying the data needs includes identifying where there are uncertainties, where additional data collection may help to reduce those uncertainties. It also includes identifying the metrics by which the remedy will be judged, so interim metrics as well as remedial goals. The framework should include a design for the monitoring program to ensure that we're collecting the right data. So the data that we have, our baseline data or our pre-remedy data, need to be comparable with our post-remedy monitoring data. And again, we need to be measuring the right things. We need to know how we want to evaluate the remedy and make sure we're measuring that. The framework can identify the data evaluations and the decision points and potential adaptive actions that may be implemented as we evaluate the system response to a remedy. And finally, and importantly, there's the decisions need to be memorialized, or the framework needs to be memorialized in the CERCLA decision documents. So Craig had discussed the process that's in the EPA adaptive management document that was issued in 2022. And this document also includes a framework which has the elements that I discussed. For example, the framework talks about identifying key indicators, monitoring frequency, so describing the monitoring program, decision points, and trigger criteria. The framework also contemplates how we'll evaluate the monitoring data and where we might make decisions and how we might reevaluate our site management plan. So an example of an adaptive management framework was developed for the Passaic River. So the Passaic River, shown over here on the right, is a 17-mile tidal river. The boxes are different operable units. There was an adaptive management plan that was part of a ROD for the upper 9 miles, which is this green box here. The river is complex, it's tidal, it has multiple contaminants, it has a long dredging history, a long industrial history. And so a ROD was issued in September of 2021 that included an interim remedy for the upper 9 miles, which was essentially a hotspot removal, but it also included adaptive management as part of the selected remedy. The adaptive management plan was developed as part of the feasibility study, so it was developed relatively early on in the remedial process. And the adaptive management plan includes a series of flowcharts. This is one example that I'm showing, that identify a set of hypotheses, identify the data needs, key questions, potential uncertainties, and then potential adaptive responses. And so this one example is for looking at the implementation of the remedy, the post-remedy recovery. So the question is, are we going to see the recovery that we're anticipating? And so the flowcharts allow us to answer that question. And if we're not seeing what we're expecting in the data, then the adaptive management plan suggests a diagnostic assessment. So our first reaction isn't, oh, we need to go do more, something went wrong. Our reaction is to understand why the system didn't perform as expected. And then to contemplate a series of potential actions, including maybe we need to continue monitoring. Maybe we need to adjust our monitoring program. We need to refine our CSM. Maybe we need to refine our numerical models. So we need to understand, we need to do a series of activities to understand why the system didn't perform as it was anticipated. So I'm going to talk briefly about the monitoring components of remedy implementation and how they apply to adaptive management. So a baseline data set is really important in adaptive management to understand what the system looks like prior to the implementation of the remedy so that we have a comparison. We know what our starting point is, and we know where to start evaluating the recovery that we're seeing in the system. Developing a good set of, the ideal set of baseline data has many challenges. One of the challenges is that the CERCLA process at contaminated sediment sites can be quite lengthy. So just for fun, I Googled how long does it take to clean up a Superfund site. And I found this 1997 document that was concerned that the time to clean up a Superfund site had gone from 2 years to 10 years in the 80s and 90s. And for those of us who have worked on these complex Superfund sites, we know the time scale is on the order of decades. And so what that means is there can be many years between the completion of the remedial investigation, the completion of the baseline data, the baseline investigation, and the pre-design investigations, and the implementation of the remedy. So that's one of the challenges in developing the good baseline data. Another is that there's just going to be changes in the system over time. So the right-hand figure shows the hydrograph on the Passaic River, and the vertical bars are when bathymetry data was collected over the course of the remedial investigation. And clearly, if we developed our baseline data following a large storm event, it would look really different than if we developed it following several years of low flow when we'd see sedimentation. So there's no maybe right answer to how we get the best baseline data. It's certainly a challenge on these big sites. So during construction, we'll be monitoring to make sure we meet the performance metrics of the construction. While this phase isn't where we apply adaptive management necessarily, these data are important to make sure the remedy was implemented as it was envisioned. And if there are changes to the remedy, to understand that again, so that we have a starting point when we start doing our post-remedy monitoring and looking at the recovery of our system. So for example, if we're doing a hotspot removal and we're chasing high concentrations, we may end up removing more sediment volume than we had anticipated, than was evaluated in our pre-remedy evaluations. Finally is post-remedy monitoring, and this is when adaptive management really kicks in. This is where we use the data to determine if we're on the right course or if we need to make revisions. And I think about the post-remedy monitoring in 3 different timeframes. The first is immediate post-remedy. This is where we expect to see a change in the system. Certainly, if we're looking at average surface sediment concentrations, we're going to see an immediate change following a removal or a capping event. And in fish tissue, we would expect to see a decline. I know we've seen data that suggests that during dredging events, tissue concentrations may go up, but we would expect them to settle in and decline following the remedy. After that, we have a period of system recovery. This is when we're seeing the system respond to the remedy over time, when we're looking at our interim metrics, we're contemplating our remedial goals and evaluating what progress we're making towards those goals. This is when I think we would probably see the most application of adaptive management. So we're asking the question of, are we getting to where we want to go, and are we getting there in the time we're expecting? And if not, why not? Do a diagnostic assessment or reevaluation of the data, refine our conceptual model and our numerical models, and implement additional remediation as needed. Beyond that, we have what I've called a future system. We're now decades out past our implementation of our remedy. And we may have model predictions that go out this far and say what we might expect to see in the system. But at this point, we have a really different system. We may have sources that were small when we were doing our initial evaluation that now have more of an impact because we've removed our larger sources. We may see different species that have come into our system. And we may have external changes such as climate change that are affecting our system. So at this point, it's time to reevaluate the system and to understand where we can actually get to relative to our goals. So just to provide a brief summary, a decision framework is required to move forward in the context of high uncertainty that we have at these sites. However, we know that the system response is complex, and the framework needs to allow for the opportunity to learn from new data and to make appropriate decisions. The framework can't be so prescriptive that says if you see A, you need to do B. Rather, if you see A, think about B and C and D, and maybe do E or F. So there needs to be flexibility in the framework to learn from the data that we're collecting. And finally, the million or maybe the billion-dollar question is how is adaptive management plans going to play out at these complex sites? So I mentioned the Passaic River, and Doug's about to talk about Berries Creek, where there's adaptive management as part of both of the selected remedies. So we have the opportunity over the next several years to see how it's going to play out. So with that, Doug's going to talk about Berries Creek.
I need the remote. Okay, there. Thank you. Okay. Okay. Thank you. I'm the EPA project manager for the Berries Creek study area. I'm happy to be here today to share my experience in managing one of the earlier examples of a contaminated sediment site using adaptive management. We had a record of decision in 2018, which utilized an adaptive management process for our basis. The Berries Creek study area is in North Jersey near New York City. It's one of the most densely populated portions of the country. The Manhattan skyline is actually visible from the site. And there is also another Superfund site, which is in the same watershed, and the remedial designs for the two sites have been integrated. Even though it is located in an urban area, the site is part of the New Jersey Meadowlands, and it's surrounded by over 700 acres of tidal wetlands. So I'm showing you some of the major physical characteristics of the area, which along with the understanding of the contaminants of concern, which are mercury, methylmercury, and PCBs, and a history of the contaminant release, are important factors in describing a conceptual site model, or CSM. As the previous two speakers have said, CSMs are really important in this whole process. So Berries Creek developed a conceptual site model, as we should for any good sediment site study. CSM development is not just an exercise in drawing a pretty picture. It includes determining the factors that are controlling contaminants in various media that are put into driving the risks of the system. It also includes collecting the data to put numbers into the CSM to the extent that's possible, and determining relative importance. Any discussion of whether adaptive management is appropriate for your site should start with a discussion of the factors influencing your CSM and the uncertainties around those factors. After the remedy is implemented and you get the results of your monitoring data, the CSMs will then be reevaluated and updated as appropriate. At the Berries Creek study area, we have conducted multiple rounds of data collection and developed conceptual site models to describe key processes and how they are related to human ecological receptors. Multiple CSMs are often needed to describe those processes. So why was adaptive site management proposed for the Berries Creek study area? The site had undergone extensive studies under an iterative Superfund investigation. So we had well-developed and refined CSMs supported by multiple lines of evidence. We had the ability to predict outcomes of initial remediation. So these seem to be both things that would support a final remedy in most cases. But what it doesn't talk about is the uncertainties that could impact remedy effectiveness. I've listed a number of uncertainties here at Berries Creek. There are probably lots of others, but I just wanted to point some of these out. And I wanted to mention that the first three items basically combine to say that it's really hard to determine the relationship between sediment contaminant concentrations and risk. So part of the process is that we plan for dealing with the uncertainties by collecting data through an adaptive management process. Using adaptive management has allowed us to move forward with an interim remedy, cleaning up the areas that have the highest risk and are acting as secondary sources. So The Berries Creek interim source remedy was selected. It's a very functional way to document Superfund cleanup decisions and adaptive site management process. Sometimes non-critical removal actions are used to use this process, but interim remedies are very functional. So they address the areas of highest risk first. Additional decision documents are unfortunately necessary later on in the process. And an important part of those is that we collect data to address uncertainties and make future remedy decisions. I would like to say that adaptive management remedies are not contingency remedies, they are not trial and error, and they are not incremental funding. So I'm showing this one slide to talk about the Berries Creek cleanup. The interim remedy for the Berries Creek study area is a substantial project that will include almost 450,000 cubic yard of sediment removal and cost more than $350 million. The blue and yellow areas are the main waterways and tributaries where we conduct bank-to-bank dredging. We will conduct bank-to-bank dredging of up to 2 feet of soft sediment up to the tide gates. After that, we will backfill to previous elevations with clean sand and therefore should not introduce any instability into the system. One area in green here, the Upper Peach Island Creek Marsh, is a freshwater marsh and is actually behind a tide gate, but it is an area where contamination was deposited on the marsh surfaces prior to tide gate installation. We will also be addressing the UOP waterways, which are in this area, in the same ways that we are addressing the Berries Creek waterways. The dredge material will be disposed of off-site, and the remedy will also include a marsh demonstration project to evaluate remedy effectiveness for the tidal marshes for future remedies. So the monitoring is an essential part of the adaptive management process. In preparing for this talk, I was trying to find something to convey this whole concept in a way that, because we need to collect so much data as part of the process. And this one quote came to my mind. "I know you think that you know, but how do you know that what you know is true?" And I didn't get that from any literature on adaptive management. It's actually from a lyric from a song by Joe Jackson. However, it really emphasizes the point that even in our best efforts, the system may not really function how we thought it would. And that by collecting the appropriate data as part of an adaptive management process, that's how we can have a better understanding of what is actually true. So we have I've listed here a number of the monitoring programs that will be used to evaluate the performance and effectiveness of the cleanup. When you look at these programs closer, you can actually see that they are basically additional rounds of data collection that were used to evaluate the most important functions described in the conceptual site models. And I'm going back to the conceptual site model. Like I said before, you have to go back to that and update it and evaluate it and use it for your future decisions. As I described earlier, there's also a marsh demonstration project, which will remediate about 4 acres of tidal marsh and feed information on how the waterway sediment remedy may have reduced risk in the marshes by controlling contaminant deposition on tidal marsh surfaces. It would also provide information on potential ways to address those marshes, if necessary, in future decisions for the site. It's important to realize that there are different stages of monitoring, like Marcia described, and at Berries Creek, we've been doing baseline monitoring for many years. During construction, we will do performance monitoring, during which time we expect the magnitude and range and concentrations to temporarily increase. Following that construction, we expect to have a period where the system stabilizes to a new post-construction condition. And then after that, when the system is stabilized, we can collect the data that will be used for new risk assessments and determining final cleanups numbers as necessary. So, in summary, at Berries Creek, we are using an adaptive management process and implementing a remedy, an interim remedy of the waterways in Upper Peach Island Creek Marsh. We're implementing a demonstration project in the tidal marshes. We're using site-wide monitoring to support application of adaptive management principles to reduce uncertainty and optimize the overall remedy. And our monitoring after the system is stabilized post-remedy will be used to conduct updated risk assessments, evaluate further remedial alternatives. The future decision documents will be necessary and they'll be required for the tidal marshes and waterway reaches not in phase one, a final decision for the phase one areas, and to determine remedial action levels for areas with unacceptable risk. The data collected from the monitoring programs will provide the information for the final remedy determinations. So I think that the Berries Creek process is a very useful one in moving forward and getting into action and doing a significant cleanup. And, I see its application here. It's not for everywhere, but I think that, it's something to be thought about if it can move you ahead. And thank you. And I will turn it back over to Stefan. I think.
Great. Thanks, Doug.
Okay.
Okay. So that was some really good presentations. What did we learn? We learned that remedy failures can be due to both the unforeseen non-technical risks and also the known technical risks. We really have to account for a lot of things that may happen. Adaptive management is not trial and error. It's just a really well thought out process that identifies potential risks that could occur and develops some options for that. A thoughtful conceptual site model, robust baseline data, and a collaborative framework are necessary to identify the trigger criteria and actions that may need to occur. Overly prescriptive actions may actually be harmful and not account for those unforeseen risks. And the adaptive management plan, it's not a static document, but it should be iteratively refined based on the monitoring and the risk evaluation. So now is the part where we'd like to hear from you and have a discussion. We do have a couple questions already that have been asked, so I'll go through those. If you have a question, you can either add your question to the Q&A button, or you can raise your hand and we can call on you. So I'll just go through the first one here. We had a question from Ted, and if you want to add to this, you can also raise your hand. Ted says, the descriptions of adaptive management so far seem to monitor the outcome of a current best guess as to what to do. Does it also include active learning in which current actions are designed, perhaps varied over space, to provide and increase the value of information to be obtained?
Let me jump in on that. I mean, Ted, I think you hit on the essence of adaptive management. In fact, the essence of adaptive management is that we don't understand a priori the outcomes of a project, and we recognize that there's high uncertainty in that. So by virtue of that, we have to learn as we go and adapt as we go. Now, there are guardrails on that. This is not, as we've discussed, as Doug discussed, as Marcia said, it's not trial and error. We're not just making stuff up and go for it. It very much is a thoughtful process, learning as much as we can. But the adaptive management process is very much to address exactly the challenge you're talking about.
I would like to add that it's, the idea of a planned manipulation where you monitor the impacts of, the way you change the system. Modification might be a better word than manipulation, but I think that is a really good, practical way of implementing some adaptive management processes. But, you need to make sure that it's not just a trial type process, because there is a lot of money involved and there are risks that could be, move with these systems as well.
Great, thank you. We have a question from Hilda. Other than Berries Creek and Lower Passaic, Are the speakers aware of any other sites that adaptive management has been applied to?
So I'm aware that it has been applied to the Anacostia. I'm not familiar. I'm not familiar with that rod, but my understanding is it does include an adaptive management, an interim remedy, and an adaptive management component.
I'll jump in. I mean, in the offshore energy realm, as I presented, adaptive management is being applied at present at multiple sites. So there's a lot of corollaries and lessons learned there. One of the big ones is adaptive management committee is set up that are people who really understand the ins and outs of the site, that are really looking at the monitoring and can look at it in a holistic way so that collective decisions can be made together that involve the project developers, the regulators, and the stakeholders, an informed group from all of that, so that there isn't confusion down the road around adaptive management. And then, as I mentioned, adaptive management has been applied since the 70s for natural resource management at national parks. And the Department of Interior really has, I think, led the way on how we apply adaptive management at uncertain sites. So I know that question was probably specific to sediment sites, but
Thanks. And we have a question from Judy Durda. So the question is to Doug. What challenges did you have in convincing EPA management to take the adaptive management approach, and what were the primary factors that swayed them?
I don't know if I have an exact answer for that, Judy. I think that there was discussion of adaptive management for a while in, I'm going to say, the later years of this project. Berries Creek existed for many decades prior to getting where we are now. And I think that the inability to move forward with all these uncertainties involving the marshes, the tidal system, the mercury availability, other factors like that were very difficult to understand and see where things could go. And I think that I have to give some credit to some of my management. John Prince was an early adapter. He told me how we were going to start doing some of this. He did a lot of looking into how the adaptive management process might work for us, and he suggested some of this to us so that we had some internal discussions then. And I think it was pretty well accepted. Of course, there's advocates within the Berries Creek PRP group that have really pushed for it. But the EPA management was looking at this as a way to move a project forward that had been pretty stagnant for a number of years, and I think we found that.
Okay, thanks, Doug. Okay, we got a hand raised from Andrew Timmis. Andrew, I'm going to call on you, so if you unmute and ask your question.
Yeah, going through it, it's obviously there's a lot of the interaction between the different agencies, the consultants, and looking at the raw data. With any of these, you still have to go through the final process of cleaning up or acting on the cleanup methods or whatever is being developed. At what point do you think, and this could be either to anybody on there, what point do you start to get involved or bring in to the conversation the contracting side to understand if some of these plans or programs that are being developed can actually be implemented or may not be implemented or may have to be modified and take into, in some cases, even cost or implementability ability to actually implement some of these. I mean, there's a lot going on there. Very familiar with the Passaic and Berries Creek and even the Hudson and others for that matter. But a lot of times it still comes down to the end that whatever's designed has to be built and has to be a remedy that'll last and actually meet the final plan of design.
Yeah, somehow I feel like you were asking that of me. As you're aware, Berries Creek is a case. Well, one of the things I have to say is that when you deal with a group of people that support adaptive approaches, they're always trying to learn from their experiences and bring in the best information. And the Berries Creek group, well, and the downside of that is that you have to be ready for changes. So we had a 60% design submitted for Berries Creek, based on the orders signed after the rods were signed. And we were asked by the group to incorporate the time to allow for them to contract with a remedial action contractor to help develop the 95% design. So we granted that time, and they are, in that process of doing that. They've hired a remedial action contractor. I've not seen any of the changes that will be proposed yet, but I understand there are a number of those. And what that does is actually allow the remedial design to reflect the expertise and the equipment available from the remedial action contractor that is ultimately selected. So I think that there is a lot of value in bringing remedial action contractors into the discussion. You have the ability to, you've gone through it in the field and see what really changes those processes in field decisions. So I think that is a very worthwhile process. It does take time, it takes energy, but hopefully it will all work out for the best for us in Berries Creek. Thanks.
Thank you.
Yeah, Andrew, I might jump in on that a little bit, because that's an excellent point. And I think there's another question I saw in the chat about, like, what areas do we see that are pinch points or potential failures for adaptive management? And it really is the collaboration aspect and getting the PRPs, the regulatory agencies, and the stakeholders all together to really completely understand what the adaptive management is all about and what the goals are. And honestly, I think from what we've seen in other industries and other areas where adaptive management has been applied, those are the pinch points where there's failures, is there's one party driving an adaptive management forward and trying to, I'm going to be a little bit flippant here, shove it down everyone else's throats. That's a recipe for failure. It's got to be a collaborative and educational process that allows for changing goals along the way. And yeah, that might mean a rod amendment or a rod change down the road, but that can be warranted if everyone's on board with it, and it can be successful. We haven't seen that, but just, for future posterity, we need to understand that those are possibilities.
Yeah, I agree with that, Craig, that I think the biggest place for failure down the road is potentially not having stakeholders agree. Everybody's at this point agreed on the front end of it when it goes into the record of decision, but how it plays out and can everybody agree on future actions and what's done with the data, again, remains to be seen. But I think from a technical perspective, just as you had said earlier, we can design through that. If the remedy wasn't enough or wasn't the right remedy or something went wrong, we can design around all of that. We can collect more data, we can analyze data, but agreeing how to move forward and on what time frame to move forward could be a challenge.
Great. I think Craig and Marcia kind of answered that next question, but Doug, maybe you have something to add. The question was, in your opinion, what factors will contribute to the failure of the adaptive management process, and how can they be prevented?
I think their answers really, address that pretty well. I don't have a whole bunch to add. I think that maybe, making sure that the project will have measurable results, that you're doing a big enough project, that you're not just, it's not just a glorified pilot type project, is something that's important. You need to have measurable results to actually be able to determine whether the processes have changed, to understand the new system afterwards and things. So that's a key point that I would also add.
Awesome. Thanks, Doug. All right. I think that's all the questions. Oh, there we go. Ryan jumped in. Thanks, Ryan. All right. Does adaptive management include institutional controls? How effective are they given the community ownership of water bodies? You want to take that one?
But, I'll jump in. I mean, I think it necessarily includes institutional controls because many times those will be discussed in detail in a ROD. Moving forward, we have to acknowledge that there could be change of ownership in properties and change of use in properties on a private sense. And I think we all get it. There is a tension between private and public interests in the United States as far as property and properties adjacent to Superfund sites. So once again, that's another aspect where I think collaboration is key. I'm sure we have a few attorneys on the phone. There are legal aspects to that also, if you notice, fall into that non-technical risk category. And legal aspects are a big part of those non-technical risks. Unfortunately, none of the three of us are legal experts. But I think getting into institutional controls, getting into change of ownership, we've seen it at sites. United Heckathorn is a good site that the EPA is managing in San Francisco Bay, where the remedy didn't meet the goals. Some of the site uses have changed. Some of the uses regionally have changed. And the EPA and local stakeholders are navigating a complex process of how do we go about best addressing where that site is today, which is 27 years after the initial cleanup.
Right.
I'm actually going to go back to that last one for 1 second there. I think that the institutional controls wouldn't be laid out in the adaptive management plan, but the collection of the information and decision points that would be in that adaptive management plan might have a decision point that might select additional controls, institutional controls as part of adaptive management. So, it starts to sound like semantics here, but I think that, I can't envision an institutional control being, really discussed as an adaptive management.
It would be more part of the final remedy as it's developed. So it would be included in the additional decision documents that come out through the process.
Right.
All right. We have time for one more question. How do you maintain adaptive management momentum when many of these projects have very long timelines? How do you identify success points along the way to retain engagement?
I mean, the process requires the 5-year reviews. So there's always, going to be check-in points along the timeline where the response will be evaluated relative to the interim metrics, and the plan will be revisited. How to retain engagement? Doug, you?
Well, I think that there's, different thoughts there. I think that, well, first of all, for Berries Creek, we fully believe that the interim remedy will resolve most of the issues. Okay, we think that this is a cleanup alternative that will really, leave us with very small areas of remaining risk afterwards. But we're not positive of that, and we still need to actually establish our final cleanup values. We have interim objectives, but doing bank-to-bank dredging, but that doesn't say what a cleanup value of an acceptable number is, and there are areas we haven't addressed. So I think that by doing the risk assessments afterwards, we hopefully will find not excessive risk remaining. In which case we hope to address that momentum problem by actually having most of the things have no further action. But I think it is important that you may move along and when you can make your studies and make the determination that the system is stabilized and be able to evaluate that, then you can identify when further actions are necessary. So I think that will be an issue, and like I said, we haven't implemented a remedy yet, so we haven't gotten there, but I think that's a good point.
Okay, thanks, Doug. Thanks for all those questions too. Really appreciate that lively discussion. So we're wrapping up here. Just first of all, I want to thank everybody for participating. We know your time is valuable, so hopefully it was valuable to you as well as it was for us. We do have additional presentations that are upcoming. So we have another webinar on October 17th regarding PFAS at contaminated sediment sites. That's Miranda Henning, Jared Gasper, and Rob Fox. On the same day, we actually have a couple presentations at the SMWG Fall Sponsor Forum, just happened in Detroit, Michigan. Beneficial reuse of sediments and modeling sample depths. And then on the East Coast, we have myself and Susan Welt making a couple presentations at the AEHS Eastern Conference. That's October 16th to 18th. That'll be on risk-based remedial decision-making. And then, of course, we have the Benthic Zone newsletter. So we just sent out our September issue, and we'll be releasing another one in December. So please make sure you sign up for any or all of those presentations and newsletters. That's all we have. Again, thank you very much for both the audience and the participants. Really appreciate your time. Thank you.
Thank you.
Thanks, everyone.